Okay. Hi, I'm Yijun, a doctoral student from the University of Tokyo. First, I want to express my appreciation of letting us have a chance to participate in the wonderful graphics interface 2023. And today I'm going to talk about our paper RelRoll, a relative elicitation mechanism for scoring annotation with a case study on speech emotion. I will go from motivation proposed method, interface implementation to user study, following by limitations and a summary. And please share with me your questions and comments afterwards. Let's start from the motivation. So difficult scoring annotation is ubiquitous, but challenging. For example, rating physical mobility score of clinical videos, experts rate the severity of patients' mobility dysfunctions and recognize their need for supervision or assistance. And also speech intelligibility. So it tries to give a score of intelligibility of the children's speech.
Say bird.
Bird.
Very nice. Say teeth.
Teeth.
What are these?
Teeth.
Yes, so image quality assessment. It is designed for evaluating human perceptual quality of images, which also needs subjective annotations. So ideally, this task would be conducted in a laboratory and trained experts with specific domain knowledge are recruited to finish the task under supervision. But it can be time-consuming, expensive, and limited in the number of annotators. To enable a more efficient and more cost-effective collecting data process, it is desirable to get non-expert annotators involved. What we mean by non-expert annotators here is the same as other work. So they're a person who has no prior annotation experience in specific domain and who has no sufficient domain knowledge. Thus, we propose our method, RelRoll, combining experts and non-experts. If we try to get non-experts involved, we should lower the difficulty of the original task. Then it leads to two parts of RelRoll. The first one is a relative labeling interface highlighting the emotion changing sentences. And the second part is an approach to estimating absolute labels from relative labels obtained from non-experts. The overall concept and progress is here. One, expert annotators first give reliable absolute labels to training data. And two, we trained a neural network using the training data. Three, the network provide hints, those highlights on the interface to help non-expert annotators. Four, non-expert annotators give relative labels to new data. Finally, the network transforms relative labels to absolute labels, and we get additional labeled data. This is the interface. There are 4 design points. First, it is a non-swap playing. There is no stop options. Users are required to give their labels before a sentence ends. Second, we highlight predicted sentences that of different emotion compared to the previous ones. And there are 5 levels of relative labels that users can give: much lower, lower, same, higher, and much higher. Third, we have the keyboard interaction here for faster operation than Morse operation. Up arrow for higher label, and down arrow for lower label, and left arrow for rewinding, and right arrow for fast forwarding. Last, we show transcripts of speakers' current sentences and last sentences for reference to help user recall how previous sentences sound. Here is a short video demo of how to use it. The user is labeling the arousal of female speaker.
Did you get the letter?
Yes! There's a big envelope. It says, "You're in."
Yeah!
I know!
That's so awesome.
So, I have to move back to the ghetto, but,
Oh my god!
you know.
What are you gonna do? What are you...
Yes, so let me talk about the implementation behind. So our network take audio features of sentences as input and predict the pleasure and arousal values as output. We train the network using the audio and absolute labels in the training set. We use features extracted by OpenSmile for each frame, including fundamental frequency, MFCC, and others, and then calculate high-level descriptor for sentence-level features. Until now, we shared the same network structure and training progress as the previous research, but we degrade a prediction goal here from numerical difference to binary classification, like whether they are different or not different. We apply the results to highlight sentences on the interface, those yellow boxes. And let me introduce how to quantify the relative labels to get absolute labels. So suppose there are n sentences in a set, and the ranking R of them by emotion values can be like this. We could use an extended Plackett-Lewis model to describe this ranking, where pi is the maximum likelihood estimation of the emotion. Thus, we apply a fine transformation on the maximum likelihood estimation of the set to make it follow the predicted distribution by the network. So we conducted a user study to prove the effectiveness of our mechanism. We compare three conditions: highlight, relative, and absolute. So highlight is our proposed method. Relative is an ablation condition without highlights, but still using relative labels. And absolute is just a baseline like other traditional absolute labeling interface. So we conducted a predicted subject user study with 36 non-experts with 12 people on each condition. And experiment was conducted remotely because of the COVID-19, and participants were recruited through the Amazon Mechanical Turk. Here's the result. As for the annotation accuracy, we found that highlight condition shows the best performance. We measured inter-annotator agreement by three metrics: percent agreement, Krippendorf and alpha, and Fleiss-Kappa. We found that highlight condition shows higher agreement than other conditions. We also found learning effect of the highlight condition. Time usage and on each task and rewinding time decreased as participants went on the tasks. So it means that users were not confident about those highlights at first, and then learned to how to label with them as the tasks went on. Yeah, and we also found better user experience through a post-experiment questionnaire. We asked them to give their ratings on easiness, intuitiveness, and helpfulness. Highlight and relative conditions have better results than absolute conditions. Especially, we found statistical significance on helpfulness between highlight and relative condition. So we believe this is the contribution of the highlights. So let me talk about limitations of this project. First, our mechanism is trying to combine experts and non-experts, so we still need experts. And second, even though we validate our mechanism through a user study, there are nuances in design decisions we have not validated. For example, there can be different designs on number of levels of relative labels, which can be interesting to explore. Third, we did not try a lot of audio examples in the user study, and we haven't tried to use RelRoll to collect large data. This can be our future work. So let me make a summary. So we present a mechanism allowing expert annotators to give reliable scoring annotations. The key idea is to reduce labeling difficulty by suggesting changes and estimating absolute labels from relative labels. And user study results show that the interface of RelRoll can improve the inter-annotator agreement and obtain reliable and valid labels. RelRoll interface can leverage the user experience from quantitative results and qualitative feedbacks. Okay, thank you for listening. Please feel free to give feedback and ask questions. And thanks again.